What does the phrase evaluated with hard carbon anodes and cathode materials selected from layered transition metal oxides, transition metal fluorophosphates, and Prussian blue and its analogs imply about the breadth of material options being explored for Ni-ion batteries? What are the testing protocols or standards used to evaluate these prototype cells, and how do researchers measure factors like energy output, stability, and degradation over time? How do laboratory test cells contribute to improving the design of Ni-ion batteries, and how do they assist in identifying potential improvements or modifications to materials, construction, or chemistry? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? Why is it important to have a range of materials available for both anodes and cathodes in Ni-ion batteries, and how does this variety influence the adaptability of the technology to different applications or use cases? How do advances in material science and electrochemistry influence the future of Ni-ion battery development, and what might these advancements mean for the scalability and commercialization of Ni-ion batteries? What does the development of Ni-ion batteries with these specific materials tell us about the direction of battery technology? And how close are we to seeing Ni-ion batteries widely used in practical applications like electric vehicles or energy storage systems? How does the use of materials like hard carbon anodes and transition metal-based cathodes represent a departure from the material choices in conventional Li-ion batteries, and what benefits or trade-offs does this shift entail? What are layered transition metal dioxides, NaMo2, and what are the possible elements for M in these compounds? How does the crystallographic structure differ between the O3 and P2 versions of NaMo2? What does it mean for NaMo2 to exist in both O3 and P2 crystallographic versions, and how do these structures relate to the overall material properties? In the context of the O3 phase NaMo2, where exactly does Na reside, and what is meant by octahedral sites? What are octahedral sites in terms of crystal structure, and how does the placement of Na in these sites affect the material's behavior? How does the crystal structure in the P2 phase differ from that in the O3 phase, particularly regarding the position of Na? What are prismatic sites in a crystal structure, and why is it significant that Na resides in prismatic sites in the P2 phase?